Applications of absolute value. So there's two basic setups for this. So when you're looking for the maximum or the minimum, you're going to use an equal sign. When you are looking for a range of possible values, so not just the end values, all the ones in the middle too, you're going to use a less than or equal to. And it is always less than or equal to. It's never a greater than, and it's never just a less than. So the way this is set up is it's going to be your variable minus your goal. So this is like your ideal. This is what you would like to have. This is what you want. Now, because we're not in a perfect world, we always allow for some kind of variance, some kind of tolerance. So you need what you want and then the variance. So the tolerance is like, okay, well, it can be too higher or too lower than whatever it is you want. And this is the setup. Same thing for the inequalities. It's still the x minus the goal and then the tolerance on the right side. So let's look at example 1. The machine is used to fill each of several bags with 16 ounces of sugar. After the bags are filled, another machine weighs them. If the bag weighs 0.3 ounces more or less than the desired weight, then it is rejected. Write an absolute value equation to represent this situation, then determine the heaviest and the lightest bag the machine will approve. So we need the goal. We need our two pieces. So the first piece I need is my goal. What do I want these bags to be weighed at? Well, I want it to be weighed with 16 ounces of sugar. That is the goal. 16 is what I would like. But because this is not a perfect world, we have some variance, some tolerance allowed for a different number. So 3 ounces more or less than the desired weight, then it is going to be rejected. So that's my tolerance, 0.3. So we're going to plug these into our equation. Absolute value of x minus the goal, which is 16, is equal to the tolerance of 0.3. And the reason we're using an equation is because I just want the heaviest and the lightest. I don't care about the values in between. I just want what's the heaviest bag that I'm allowed to have and what's the lightest bag that I'm allowed to have. So this is the first part of the question. Write an absolute value equation. Done. So to figure out the heaviest and the lightest, we're going to solve this for x. So I'm going to split my equation into two. X minus 16 equals 0.3, and then x minus 16 equals negative 0.3. And we're going to solve these individually. So I'm going to add 16 to both sides. So for one, I get a bag weight of 16.3. And then for the other one, when I add 16, negative 0.3 plus 16 is like subtracting. So I get a bag weight of 15.7. So the answer to this is the heaviest bag is 16.3 ounces. That's the heaviest I can get it. And the lightest is 15.7 ounces. That's the lightest it can be. If you have something lower or higher than those two, then the bag must be rejected, and it's not a good bag of sugar. So take a minute, pause the video, try number 2. Here is your solution for number 2. We used the equation because we're just looking for the max and the min. We're not looking for a range of values, so we use the equation. Let's look at number 3. The ideal diameter of a piston for one type of car is 88 millimeters. The actual diameter can vary from the ideal diameter by at most 0.007 millimeters. Find the range of acceptable diameters for the piston. So again, I need my goal and I need my tolerance. So the ideal diameter, that's your goal, of 88 millimeters. So my goal is 88. The tolerance is how much it can vary. So I can vary from the ideal by at most 0.007. Now, it says find the range of the acceptable diameters. So since we're using range, this is going to be the inequality. Now, another reason at most is less than or equal to. That's another reason we always use less than or equal to every time. So we've got x minus the goal, which is 88, and the absolute value is less than or equal to the tolerance, the variance of 0.007. And this is the inequality that represents the range of these values. Now, to actually find the range, we're going to solve this like we do a regular inequality. We're going to take the inside, less than or equal to 0.007, and then we're going to take the inside, greater than or equal to negative 0.007. And we're going to solve like normal. So add 88 to both sides. You end up with x less than or equal to 88.007, and then we're going to add 88 on both sides here. X greater than or equal to, so this is really subtracting, 87.993. So in order to actually write out the range correctly, let's think about what this looks like graphically. So if I were to graph this on a number line, this would be the 87.993. This would be the 88.007. My boundary points are solid. And now, if I want less than 88, I'm going to go this way. If I want greater than 87, I'm going to go this way. So my shading is everything here in the middle, which is why it's a range of values. You have a minimum, you have a maximum. You're not allowed to go outside of those. So that's why the shading is in between, which is also why we always use less thans, because if you used greater thans, your shading would be outside. So if we write this the correct way, we're going to start with the low value of 87.993 is less than or equal to whatever I'm allowed to be, less than or equal to the high value of 88.007. So this is the range of all the possible diameters of this car's piston. Take a minute and try number 4. Pause the video. And here's your solution for number 4. Here's the inequality, and it's an inequality because we're talking about the range of widths, not just the least and the greatest. And this is what you should have had for the range. 147.5 is less than or equal to x, which is also less than or equal to 152.5.